Hello everybody, my name is Arne, I'm part of the Motherson family. At Motherson we are proud to be part of one of the largest automotive supplier for interior and exterior components. The continuous and increasing trend of autonomous driving and ADAS is affecting our parts directly. Those safety systems and their sensors are exposed to environmental influences which can affect the functionality. For example, a radar sensor can stop working in winter due to ice and snow. For this reason, we are implementing heating elements in our parts, like in radar cover, which ensure that the radar function is given. And this is where we came together with Solace, an innovative startup, and where we accomplished an POC for an inductive sensor heating. For state-of-the-art heating solutions, it is necessary to have a physical connector. Implementing such a connector have a few disadvantages. The first disadvantage is we have a complex part geometry and processes which are due to a multi-component assembly. The second disadvantage is we have a physical connector can be unappealing visually. And the third disadvantage is we have a low efficiency, so we have a high heating duration, which is caused because we have to put the heating element on the backside of the part. To accomplish our POC, we had to face a few challenges. First challenge was the heating function, of course, should be given. And the second challenge was the radar function shouldn't be affected from a wireless coupling standpoint. And last but not least challenge was the part quality shouldn't be affected. So now I'm going to hand over to Dan, who's telling you a little bit more about the details of this POC.
Thanks, Arne. So usually in wireless power, you have a transmitter and a receiver, and we don't want to create heat, ever. That's usually a bad thing. In this case, we did the opposite. We wanted to create as much heat as possible. So we have a custom wireless power design, and here you can see the coil sitting around the radar, and we went through several iterations of that to get maximum efficiency. But then we also developed this novel receiver, which is the nichrome wire, which is actually embedded within the car part. And we worked with Motherson, who developed a novel embedded injector molding technique. So this wire pattern, we went through about 8 different variations of it to make sure we have proper heating efficiency, but also it doesn't impact the radar signal, because that's the whole purpose of this POC. And so in the end, we were able to meet all of the OEM specified performance requirements. So we're delivering up to 70 watts of heat. It heats to 50 degrees Celsius in less than 2 minutes. So perfect for de-icing any radar cover, for example. The transfer distance in this case is about 1 centimeter. And as I mentioned, we can do this without impacting the radar attenuation. And so we have a really, really cool demo set up there right as you come in, where you can see this in action. It's heating up live. You can see the temperature increasing. And we're really proud of this proof of concept we put together, and very happy with the collaboration with the Motherson team. Thank you.